Dear students, welcome to another lecture of Module 6. In this session, we are going to discussing about the effects of Earth magnetic field on ionospheric radio waves. Okay, we shall see the details. We already discussed what is ionospheric wave propagation and what is an ionosphere. Ionosphere, that is a region of the atmosphere that consisting of electrons and ions, right? Then, when the radio waves or the electromagnetic waves reaches in the ionospheric region, the electrons are set in motion due to the electric field of the radio waves and the earth magnetic fields. And these radio waves and the earth magnetic field exert a force on these vibrating electrons, and this produces a twisting effect on their path. So the twisting effect on their path, and this reacts on the incident waves. These electrons reacts on the incident radio waves. Thus, the earth magnetic field and the electric field of the radio waves split up the incident waves into two components. That is, two components are the ordinary waves and the extraordinary waves. And the properties of ordinary waves are same as a wave without superimposed magnetic field, and the extraordinary waves differ from the ordinary waves only in the upper region of F2 layers or F layers. The first point is due to the effect of magnetic fields and the effect of electric field, ionospheric region electrons a twisting effect produce. That twisting effect ionospheric region incident waves and waves split up. That is, ordinary waves and extraordinary waves split. That is the first point, that is splitting of incident radio waves. So the splitting of radio waves, two waves, ordinary waves and extraordinary waves. Extraordinary waves and ordinary waves bend in different ways, and it passes through the ionosphere and hence travel through the different path. And the rate of energy absorption and the velocities also differ. So there is a double refraction. And the two waves, that is ordinary and extraordinary waves, have elliptical polarization and rotate in the opposite direction. Thus, this phenomenon of splitting up of incident waves into two different components by the earth magnetic field is called magneto-ionic splitting, and this process is magneto-ionic splitting. Amplitude of extraordinary waves related to the ordinary waves depends on the magnitude of magnetic effect. In the magnitude and amplitude depend. Okay, this is first point. First point is splitting of incident waves into ordinary waves and extraordinary waves. Okay, next, second point is effect of polarization of incident waves. At the point is polarization of incident wave in the effect. That is, beside the splitting of incident radio waves into ordinary and extraordinary wave components, the earth magnetic field affect the polarization of incident waves. That is, electrons are in simple harmonic motion in the absence of magnetic field that will modified as elliptical or spiral motion in the presence of earth magnetic field. Normally vibration ഉള്ളത് മാറി എന്തിലേക്ക് മാറും, ഒരു elliptical polarization അല്ലെങ്കിൽ ഒരു spiral ഫോമിലേക്ക് മാറും. That is affecting the polarization of incident wave. That is the second point. That is, the electrons in simple harmonic motions is now modified into an elliptical or spiral motion by the earth magnetic field. And the third point is the average strength of earth magnetic field is 40 angstrom per meter, and that affects the radio wave propagation and make the ionosphere to behave like an isotropic medium, that is offering different dielectric constant in different directions. That is, so ionosphere behave like an isotropic medium. This is the third point. And the fourth point is the earth magnetic field causes the electrons and ions in the ionosphere to trace the complicated trajectory, and corresponding frequency is called gyro frequency or cyclotron frequency. And the frequency depends on the magnetic field and the charge to mass ratio of the particles. But that is fourth point. Fourth point is the earth magnetic field causes the electrons and ions in the ionosphere to trace a complicated trajectory. Particular frequencies, frequencies gyro frequency, and the gyro frequency depends on the magnetic field and the charge to mass ratio of the particles, and this frequency is about 1.4 megahertz ആണ്. So the gyro frequency or cyclotron frequency the equation എന്താന്ന് നോക്കാം. What is gyro frequency and the cyclotron frequency equations? Okay, it is defined as a frequency whose period is equal to the period of revolution of electrons in a circular orbit under the influence of Earth magnetic field of flux B, and this frequency is 1 by 2 pi into B into E by M. B is the Earth magnetic flux density, that is 0.5 into 10 raised to minus 4 Weber per meter. This is the equation for cyclotron frequencies. ഇതിൻ്റെ പ്രൂഫ് ദാറ്റ് ഈസ് ലോറൻസ് ഫോഴ്സിൽ നിന്നാണ് ഈ ഇക്വേഷൻ നമ്മൾ ഡിറൈവ് ചെയ്തെടുക്കുന്നത്. That is the Earth magnetic field B that exerts a force on the moving electrons, and the magnitude of force is F is equal to E into V cross B. E is the charge, V velocity, and B is the magnetic flux density. H is the magnetic field intensity. Due to this effect, electrons revolves in the circular path of radius r. Hence, centrifugal force provided by the Lorentz force is mv square by r. Then equating the two forces, then we get V by r is equal to Eb by m. V by r, that is omega, that is 2 pi f. That is 2 pi f is equal to Eb by m, then f is equal to Eb by 2 pi m. This is the equation for the gyro frequencies. In Nauka, a gyro frequency effect. When the frequency is greater than the gyro frequency, that the electron follow this path. When the frequency is equal to, that condition is critical frequency, and this electron follows this path. When the lower frequencies, the electron follows this path. Okay, so this is the effect of Earth magnetic field on ionospheric wave propagations. Okay, thank you.